now talked about who do I need to write, do I need to know coding? We talked about do I need to know math? So with that, another question that comes up is how much time do I need to get there? Here is a sort of a image or picture or story that uh, gives an idea about that. If you already have experience code, if you are have experience, know how to code, know math, know statistics, and are good in the AI ML theory, you already are right there. Uh, uh, Products or answer questions based on the data that is available. You probably would be able to build machine learning models, traditional machine learning models, and neural networks in any field or any domain uh, where you're sort of interested to apply these methods. If you do not have experience but do have the knowledge of coding, math, statistics, and the theory, then it's you still are ahead of the curve, and uh, you will get the experience as soon as you start working on these projects, either on job or in school or in your research, or if you are participating in competitions. So, so those three are already. So you are already up here if you have that. But if you are starting out as, let's say, you are still in high school and want to get there, by the time you get to you are through with the school, maybe this ladder would have changed. But as of recording this video, things that you could do is learn Scratch programming if you are in school. Say if you are in fifth, by 10th you could try and learn basic Python programming, know how to add, subtract numbers, write simple loops. And if you are in school, say undergrad or grad, I'd suggest you definitely should learn how to write code if you are interested in getting into the field, and take courses in math and statistics to get you ready for building upon the foundations required for this. Apart from that, if you are a working professional, or if you are already graduated and haven't done any coding or haven't taken any math and statistic courses, then I would suggest you'll have to spend time to get through that as you're learning. So first, I want to start learning coding and then spend some uh, time daily on each of these topics to eventually get to the analysis part. Again, if you know math and coding, then I think you are already uh, moving swiftly through this process and uh, to get to the analytics and the predictive modeling part. If the coding is in different language, I think learning Python would be one thing to start with. Learning R is also another avenue you can take. So the first step I'd suggest is learning, getting a feel for how to handle data by using software such as Excel. I understand that's a paid software, but it's pre-installed on most of the computers these days. If not, there is also open source version of Excel available. I think it's Open Office that is also available. Then learning Python, giving it 6 months to really know the basics of how to work with Python, base Python, NumPy, Pandas, Matplotlib. That is really the foundational stuff that you need to know. That'll get you enough uh, knowledge to handle and pre-process data and perform basic analytic tasks. After you've learned that, if you take a course, maybe if you've learned that, I'd suggest giving it practice for another 6 months. And during that, you can also continue looking for a job. And as soon as you get into a entry level position as an analyst, the first year I'd suggest uh, would be again continuing will build your practice and fluency in writing the code, and then While that is happening, as an analyst, or another task that you could do is build your skill set in statistics. So the statistics is going to help you uh, convey your recommendations to the person who is asking your questions with certain level of confidence, so that they can make business decisions. And so that's where the part of trust comes in. You trust your findings, and how much you trust your findings is what you're also conveying for making the business decisions. And then as you could go another uh, level up in here, which is getting into machine learning theory. And again, this doesn't have to be level up, it could be same level but a different area. As an analyst, it is also interesting field where you can do lots of interesting stuff. If you are interested in predictive modeling, then learning traditional machine learning theory is important. That might take a year to do that. Based taking online courses, you might not learn everything, you might not learn each and every derivation, but in 1 year I think it should be doable to know, learn the basic concepts, learn how to implement them on simple toy data sets or in real world data sets. That is possible. And then uh, with that you could take on more responsibilities uh, uh, to build predictive models, and then move into the area of deep learning if that is of interest, because neural networks uh, can do things that are more complicated. And building a foundation in this, again, that is, there's a question mark for the year there, because uh, again, it depends on the project, it depends on the amount of resources you have. Resources include time and hardware available, computer hardware available to run the code. And hopefully that will help you reach a level where you are in a position where you can build custom neural network architectures that also use some level of traditional machine learning to answer domain specific questions. What I mean by that is, let's say if you are a civil engineer and you have knowledge of machine learning, deep learning, you know analytics, you know data preprocessing. Then let's say if you get data for sort of uh, putting together the uh, blueprint for creating a bridge, and for that there will be several sort of moving puzzles that would have to be taken into consideration to create maybe the architecture or the game plan for building that bridge. And uh, so maybe that will tell how much time it will take the bridge, build the bridge, the cost, or maybe the architecture, what is the best architecture that requires the least amount of resources and still provides the best lifetime for that bridge. So these are the sort of innovative things you may be able to build uh, with custom architectures. Having said that, uh, maybe in future there would be some other methods apart from neural networks that may be be developed. So if that happens, the knowledge of math, statistics, the practice or of intuition to translate thoughts into code, I think that still would be relevant and should be applicable at that time.